What if the future of AI is not about building bigger models, but building better context engines? Today, we are breaking down the anatomy of production grade context engine, the system behind serious AI agents that can remember, retrieve, reason, and respond with precision. Most people still think AI performance comes only from the model. Beginner model becomes answer and but in the production that is like not enough. Like the real question is what context did the model receive. So was the context fresh, and what was it relevant, was it secure, was it structured properly? So this is where like the context engineering comes in. So everyone is talking about like the large language models, so let's jump into it. So large language models are animesiac, like reasoning engine. So like language models are like powerful, but by default they are anemic, and they do not naturally remember your business, your document, your user performance, or what happened like across previous sessions, unless like we engineer that context around them. Prompt engineering was about writing better static instructions, but context engineering is different. It is about like managing the full information loop around the model and retrieve context system instructions. So the current state tool like output and memory. Think of it the way like prompt engineering tells the models what to do. Context engineering decides what the model gets to know, and for the agent running in loop. So this become even more important because every turn creates new data that must be refined, stored, and reused. So let's have the attention budget. So now here's the trap. Modern models are like getting larger context windows, like 100k tokens, 500k tokens, even million token context windows. But just because we can throw more tokens into the model does not mean the model will be reason better. Even tokens have to attend to other tokens as the context grow attention and get stretched thin. So that creates what I call context rot zone. The model has like more information but less precision. Important details can be buried. So reason like can degrade the answer mesh, sound confident, but the model may be like connecting the wrong piece. So the solution is like not brute force context. The solution is precision context. Do not give the model everything. Give it exactly what it needs and in the right structure at the right time. So we have some pillars of production grade like context engineering. So like a real context engine that has three pillars. Like first is knowledge, like our production rag, and there is where we handle indexing, document parsing, like and semantic chunking. And we have one more is like hybrid retrieval. This help the model escape the static training data trap. The second one we have is state and memory. This is what allows agent to maintain the longitude context across sessions. Use preferences, past decision, previous actions, and durable knowledge all live here. The third is compute orchestration. Not every task need the same model. Some tasks need speed. Some need deep reasoning. Some need low cost. A good context engine routes the right context to the right model. This is the shift. We are not just using one model anymore. We are engineering a system around multiple models, memory layers, retrieval systems, and government controls. So, like governance controls. So, like why RAG demos fail in the production? So, here's the like brutal truth. Most RAG demos look amazing, but production RAG is the different game here. So in a demo you may upload like 50 clean PDF and get good answers. In production you deal with 500,000 messy documents, tables, layouts, screenshots, scanned files, permission, outdated data, and uh, conflicting sources. So, Nave RAG does fix size chunking, like production RAG needs document aware chunking, and Navy like RAG users vector search only. Production RAG uses hybrid retrieval vector search plus keywords search, and Nave RAG grabs 2K chunks. So production RAG re-rank result with the cross endorse, and most importantly, production RAG needs governance, but hallucination is not just a bug. In enterprises, AI hallucination is a liability. So let's talk about the precision chunking. This slide shows like one of the most important part of the whole system. Precision, like chunking, and the bad chunking destroys RAG, and inner table gets split in the middle. The model may lose the relationship between rows and columns, and if a clause get cut in half, and the model may answer without the legal or the technical conditions that change the meaning. And the better approach is to start with the VLM parsing and using the vision language models to understand the document layout, table, and structure. Then we use a parent child chunking model. Small child chunks are like great for search recall, and they help us to find the exact matching detail, but we send the context to the LLM and we bring back the large parent chunk, so the model understands the full surrounding meaning. Small chunks find the needle, right? And the parent chunks explain the high stack, and this is the precision retrieval. So we have hybrid retrieval and re-ranking. So in the vector search is powerful, but the vector search alone is not enough. A dense vector search understand meaning. For example, it cannot connect heart attack with um, microcardial infraction, but sprays keywords like search like BM25, and it is like better exact terms, product IDs, names, codes, numbers, policy labels, and technical identifiers. So production retrieval combines both. Dense vectors find like semantic meaning, spark sparse like keywords like search find exact matches, and reciprocal rank fusion merges the list. Then the cross encoder re-ranking compare the query and the document together to identify the best final chunks, and the goal is simple: reduce noise before the model ever sees the context, because the best way to reduce the information is not to yell at all the models, and it is like stop feeding it garbage. So like for the stateless chat and persistent digital collaborators, there is where the chatbots become collaborators, and a normal chatbot forgets a context engineer members, but memory is not one thing. There is where like the different memory types: conversational memories, short term turn by turn history, semantic memories, and stored durable fact and synthesized knowledge. Entity memory is like store fact about specific people, systems, and objects. So like episodic like memory record what happened, action, events, logs, and procedural memory stores workflows, run, and maintenance steps. So, like summary memory compresses the large document into the reusable knowledge artifacts, and this is how like we move from chat with AI to work with AI. The agent is no longer just responding; it is building an insuspectable memory system over time. So we have the LLM wiki. So like it is one partial architecture for this is an LLM wiki. Instead of treating memory like a mysterious black box, we create a file based memory system. There are three layers. First is raw source, and the evidence layer is These are PDFs, emails, chat, logs, and original document. The agent can read and summarize them, but it could never override the source of truth. Second is the wiki, the semantic layer. This is where the structured knowledge lives, entity pages, logs, summaries, and connected notes. The third is the schema, the instruction layers. This is tells that agents like how to update memory and avoid duplicates, decay, stale, and information, and maintain the canonical pages. This is the important because memory should not be magic. Memory should be insusceptible, editable, and governed. So we have one life cycle wheel over here. Memory is not just stored once, it moves through a life cycle. Before the session, we inject relevant memory so into the context window, and this is not the structure as YAML, markdown, list, or other compact formats. During live turns, the agent distills like useful signals. Not every sentence deserves to become memory, and the system's exact durable information and ignores temporary noises. After the session, constellation like job merges new nodes into global memory, removes duplicate, resolve conflicts, and prawns like stale data. And this is the key line: forget forgetting is a failure. Sorry, like forgetting is a feature, not a bug. And a memory system that like remember everything becomes polluted, and a good memory system remembers what matters. So let's talk about the resolving memory conflicts. And now what happens like when memory conflicts? Let's say the system remember that a user usually prefer a cell seats, like but today like the user says I want a window seat. The current instruction must win. This is why we need a precedence stack at the top, latest user input. This overrides everything. Next, structured profile data. These are trusted fact and constraints them like global memory nodes and useful but advisory at the bottom. Global defaults and system instructions. This prevents memory poisoning. Memory should help the model, not trap the user in outdated assumption. So the injected memory should be clearly marked as advisory, not absolute truth. Sub-agent compassion. So like one of the smartest way to handle huge context in sub-agent compassion. Instead of forcing one model to read everything, we send like sub-agents to explore different part of the file system and research paper repositories and document collections. Each sub-agents can inspect a large amount of raw information. Then the system compresses their findings into a high fidelity artifact, and finally the lead agent receive only the clean summary, maybe like 1000 or 2000 tokens, and uses that for the planning and synthesis. This is keeps the main context window clean. Think of it like a research team. The interns collect the raw material, and the analysis summarize the findings, and the lead strategies like makes the final decision. This is how agentic context scales. So we have task based model routing here. So the future is not about the model for everything. Different models have different strengths. Some are like better for complex reasoning and code, some are faster for real time chat, some are better for multimodal and long context analysis, some are cheaper for high volume batch processing. So instead of asking like which model is best, and we should ask like which model is like best for this task, and that is the task based on the model routing. A production context engine checks the task latency requirements, cost requirements, privacy requirements, and reasoning depth, then routes the context to the right model. This is where the AI engineering starts to look like cloud architecture, and you do not use one server for everything. You do not use like one database for everything, and soon you will not use one model for everything. So we have like ultimate context engine architecture over here. So now let's put the full architecture together, and a user send inputs to the system pulls from two major sources. First is memory and state, structure profile, global nodes, previous preferences and agent memory. The second is knowledge retrieval, vector database, hybrid search, VLM, parsed and document parent child chunks and cross encoder re-ranking. Then everything is assembled into the context window. Inside the context window we have instruction, memory, rag, evidence and the user query. After that the intelligence compute router decides which model should handle the task. Maybe it goes to the fast model, maybe it goes to the deep reasoning model, maybe it goes to the cheaper batch model, and then the respond goes back to the user. And this is the background, and this is goes in the background, and asynchronous job distills and collides new memory, so the system improves over the time. This is not a chatbot, this is context engine. So we have like evolution and governance, which is like finally like none of this matters without evaluation and governance. A production AI system needs continuous evaluation. There are like three keys we have. First is context precision, and are the like those are the retrieved chunk according to relevant. Second is relevancy, like does the answer solve the user's prompt. And the third is faithfulness, is the answer like derived only from the provided context. This is the rack trade uh, tried. And then comes like the governance. The retrieval layer must enforce RBAC and ABAC. That means the model should not even receive information the user is not allowed to access. If an employee asks for executive salary data and they do not have any permission, the retrieve should return nothing, and then the LLM should safely refuse. The zero trust AI. The team that win will not just be the teams with the flashiest model, they will be the team with the strong data quality, metadata, retrieval, and evaluation across access control and automated testing. The future of AI is not just bigger models, it is better context. So let's come to the closing part of this session. So that is the anatomy of the production grade context engine. Like RAG gives the model knowledge, memory gives the agent continuity, and the routing gives the system efficiency. So the governance give it trust. And when all when all those like work together, ai stop AI stop like becoming a demo and starts becoming the infrastructure. If you are like building agents, rack systems, and all the AI products, so this layers are need to be understood, because models generate the answer but the context decide whether that answer is useful or not, and grounded or trustworthy. So thank you everyone for today's to be here, and thank you so much.
This is Abhishek Yadav signing off from Curio Mind Show. Stay curious. Until next time, keep observing, keep interacting, and keep discovering. If you enjoyed this video, make sure to hit the like button, subscribe to the channel, and don't forget to press the bell icon so you never miss an update. Thank you for watching.